Okay, let's do our power table. Let's do our power table, and then we're moving on to electronics. So I am going to have 4 volts, 16 ohms, 40 ohms, 60 ohms, okay? And over here, I'm going to have voltage. Thank you for the likes, thank you for the likes. Current and power. So 4 volts has 4 volts. 16 ohms has 0.1 amps. 4 volts has 0.1 amps. So the power delivered is negative 0.4 watts. The power delivered is negative 0.4 watts. Okay, the voltage across the 24 volts is 2.4 volts. The voltage across the 16 ohms is 1.6 volts. Remember, it has to obey KVL. So 1.6 voltage drop across the 16 ohm. Then we're going to have a 2.4 volt drop across the 40 ohm and a 2.4 volt drop across the 60 ohm, because the sum of the voltages around the loop have to equal 0. Okay, so the current, 2.4 divided by 40. 2.4 divided by 40 is 60 milliamps. 60 milliamps. Or 0.06 amps, okay? 2.4 divided by 60 is, even though I could do subtraction and get the answer, I still will sometimes type it in because I don't want to use a problem, an answer that may have a mistake in it in order to solve for something else. So that's why, even though I can use KCL to figure out what that other current is, I still walk through and do this so that I'm not using an error in order to make a calculation. So 2.4 divided by 60 is 0.04 amps, and that is correct. It does obey KCL. So we're now ready to find all of our power values. 1.6 times 0.1 is positive 0.16. Positive 0.16. 2.4 times 0.06 is 0.144. And 2.4 times 0.04 is, hold on, I'm off the screen. Gotta scroll up. Okay, so now what we want to show is that the sum of power delivered equals the sum of power absorbed. So what I'm going to add together is 0.16 plus 0.144 plus 0.096. And it does. Power delivered does equal power absorbed.